Well, hello and welcome. This is Dr. K, and today I wanted to talk to you a little bit about features. All right, so what are features? Well, features are anything, any surface, anything that we can touch on our part. So what I've done here is I've thrown in an assortment of different things I've just found around my house, since there's not a lot else that I can do. And so as we can look here, we have just a simple square piece of wood here. And what we have is we have features. Every one of these planes or surfaces are features. Now, features are going to be important later on because this is how we're going to deal with datums and reference frames, but we have features. Other parts that we have going on here. Here's a piece out of something. I'm not sure what this is from, but it has features as well. Round features, maybe not quite so round features. Different surfaces, these are all going to be features. Again, here's a little piece of stamped metal. Holes, features, cylindrical bodies, all features. And we can just see the assortment of different things. Features. Anything and everything on your part that you can touch is a feature. Now, the next thing I'd like to talk about is what we call features of size. And of course, features of size are going to be important because we are going to treat a feature of size differently than just a standard feature. And so the easiest way that I've learned how to explain what a feature of a size is to really think about your calipers here. You have two different sides that we can measure from. We have this end here where we're going to be able to grab onto things, measure outside shapes, or we can, of course, use the inside. We can measure inside shapes. And so anything that we can measure from here on this side is almost always going to be a feature of size. Now, if you think you've got to come at it and measure from this side, well, that's more than likely not a feature of size. Now, when dealing with features of size, we have a few concepts that we're going to learn is that what by definition a feature of size is that there's opposite points. And so if we remember back here, as we just talked about the caliper method of determining what a feature of size is, that we're going to use this side, there's going to be opposite points that we're going to work with, that we're going to use to measure something. There's opposing points. Now, those points could be opposite of one another. And so that's what we have here in this block is we have all of these points oppose each other everywhere. Or we could have points that don't oppose each other everywhere. And so let's see. What you might find here is that here we could consider this some sort of feature of size, right? We're using that edge, but the points aren't opposed. They're really only opposed in this one place, and they're not opposed everywhere. And so there we're going to have opposed, but they're called partially opposed points. And then you have the case where you may not have opposed points at all. And so that's going to be, all right. And so here, made up a little example here. So here we would have, is another example of what we would call partially opposed points, right? Here's our feature of size. And if we were to put this against our block, we'd be dealing with some sort of distance measure here. We could grab our caliper, we could measure that, but not all of the points here are opposed by this feature. So again, this is a partially opposed. Now, a little different part would be something that looks like this. And of course, it's just a piece of paper, and maybe we're going to put this up against a surface to measure. Here, we have a feature of size. We could measure this feature, but you'll notice that all of the points over here are not opposed by this surface here. And so that's going to be considered our non-opposed surfaces. And we'll talk about what the details of each of these means later on. So now let's take our features and our features of size and split those features of size into two categories. One category will be regular features of size. The second will be irregular features of size. So let's talk about that first category. A regular feature of size is that which is capable of being encompassed by a circular element. A cylinder is considered a regular feature of size. A sphere is a regular feature of size. Some sort of parallel elements are a regular feature of size. And so this is our regular feature of size, two parallel elements. A hole as a feature is a regular feature of size because it is a cylinder element or an array of circular elements that's going to deal with our feature. Our second feature of size is what we call an irregular feature of size. Now, irregular feature of size come in two types as well. One is the one that we can directly tolerance, and those that are directly toleranced and can have their mating envelope enclosed in what would be a regular feature of size. That is our type A irregular feature. So a little guy like this would be considered an irregular feature of size type A because we could draw a circle around this and enclose that particular feature. Same thing would happen here. I've got my paper set up. Here we have two planes, which makes up our regular feature of size, but since we don't have opposing points all the way, this would be considered an irregular feature of size of the type A. Now, the second irregular feature of size is what we call a type B irregular feature of size, and that's going to be considered anything else that really doesn't fit your circles or your spheres. And so a shape like this as a feature of size would be considered an irregular feature of size. Other things that you might consider is this shape here, how it is a feature of size, but it isn't contained inside a circle or a cylinder, so this would be an irregular feature of size, and so on. And so what you'll want to do is as you're working through parts, as you're thinking about how you're doing design, we'll consider, are we dealing with regular features of size, our circles, our planes? Are we dealing with irregular features of size? And are they going to be a type A, where we can actually encapsulate them inside what would be a regular feature? Or is it just some other random type shape that we're going to have to deal with? Maybe not so random, but another shape that we're going to have to work with. All right then, well, to quickly recap, we are dealing with features. Features are our surfaces. Make sure we understand anything that we can touch on our part is our feature. We're going to have features of size. They're going to be features that we can measure with this end of the caliper. If we can measure with this end of the caliper, it is more than likely a feature of size that is going to become important later. And then inside that classification of features of size, are they regular features of size? Are they circles? Are they planes that we're dealing with features of size? Or are there irregular features of size? And of course, there's two of those styles of irregular features of size. Can we fit them in a circle? Or can we not? Are they something different? And they're type B, which has different features that we can't encapsulate in a circular cylinder. All of these different types of features of size, whether irregular or regular, we are going to need to be identifying those features so that we can appropriately apply our GD&T later on. Well, that's all I have right now. So I really do appreciate you watching. We'll take this information, pass it into the next section, and hope you have a great day.